Let's recall that these 6 are the frequently used functions from Chapter 2 introductory assignment that you had to do. One thing to note about all of these functions is that they all go through the origin, and they all go through 1, 1. Now, some of them go through 1, negative 1, or negative 1, negative 1, or negative 1, 1, but you have to know the shape to know which point it's going to go through. So let's first identify the parent function of this graph. It is x to the third. It is the cubic function. So what transformation was done? Well, we're going to go down 2. So knowing what the cubic function looks like, instead of going through the origin, I'm shifting down 2, and then I know it goes through 1, 1, and negative 1, negative 1, but shifted down 2. So it's going to look like this. The domain is negative infinity to infinity, all real numbers, and so is the range. The second function, parent function, is x squared, the quadratic or squaring function. And this transformation is up 3. So if you take those points that we know that it goes through, the origin, it's going to go up 3. And then all the other points shift up as well. The domain for a quadratic function is negative infinity to infinity, and the range is going to be 3, including 3, all the way up to infinity. This function is also a quadratic function. But it has a transformation to the right, 3. So I'm going to take the origin, and I'm going to go to the right 3. And I'm going to take all those other key points and do the same thing as well. The domain on every quadratic is all real numbers, but the range now is 0 because I didn't go up or down. I just went to the right to infinity. So this parent function is the absolute value of x. It's the absolute value function. And we are going to go to the right. We're going to go to the left 3. It's a horizontal shift. So I know I go through the origin, but I'm going to count over left 3. And then it's similar to a quadratic, except it's the V shape. So the domain is going to be all real numbers, and my range is 0 to infinity. Okay, so the one below it is also the absolute value function. Except this transformation is a reflection. So this is actually going to be a vertical reflection. And we know it's vertical because it's on the outside. Everything on the outside is a vertical shift. Anything on the inside with x is going to be a horizontal shift. So it's still going to go through the origin, but a vertical shift is over the x-axis. So now it's going to go down like this. So your domain is still negative infinity to infinity, but now your range is coming from negative infinity and stopping at 0. All right, so this parent function is the cube root function. And since the negative this time is on the inside, this is a horizontal reflection. So I'm still going to go through the origin of the cube root function, but instead of going through 1, 1, if I'm flipping horizontally, I'm going to go through negative 1, 1, and instead of going through negative 1, negative 1, I'm going to go through the point positive 1, negative 1. So horizontal reflection is over the y-axis. The domain of this is all real numbers, and so is the range. Okay, so once again, we are doing the cube root function. But this transformation is going to be a vertical because it's on the outside, and stretch because it's a number greater than 1. So I'm going to go through the origin, but now a vertical stretch means that I'm going to take all the y values, because when you think vertical, those are y values, and I'm going to multiply them by 4. So normally when we would have a point go through 1, 1, we're going to take this this y value here, and we're going to multiply it by 4. So really now we're going to go through 1, 1, 2, 3, 4. And we're going to do the same thing with the point negative 1, negative 1. So we're going to come negative 1, 1, 2, 3, negative 4. So now this is a cube root function, so since I'm stretching it vertically, it's going to be stretched vertically, but then we need to show that it's going to curve and go a little bit more horizontally. So I can probably do a little bit more over here, like this. So the domain and range of this function is still all real numbers. So this next one, the parent function is the cubic function, or cubing function, however you want to say it. And the transformation, since it's on the inside with x, it is horizontal. And this is actually a horizontal stretch, because horizontal stretches are any number that's in between 0 and 1 on the inside. So if it was a number between 0 and 1 on the outside, it would be a vertical compression, but in this case it's opposite, so it's a horizontal stretch. And then it's a horizontal stretch by 3. So what we're going to do is our origin doesn't change, but now with the function, with the point 1, 1 that would have been there, I'm going to take my horizontal, my x value, and I'm going to multiply it by 3 because I need to stretch it. So I'm actually going to go over to 1, 2, 3, 1. I'm going to do the same thing with negative 1, negative 1. So I'm going to go over 1, 2, negative 3, down 1. So now this one stretched horizontally, but we need to show that it's going to go back up because it's the cubic function. And then it is all real numbers for the domain and range. Okay, so this matching one is a great exercise. We are going to kind of go through and narrow down a couple things. So the first one says 1/2 x to the third. So all my possibilities of a cubic function are g and just g. So that is going to be my answer for the first one. Cross that one off. All right, so the next one is negative 2/3 x plus 2. So that is a line, that is a linear function. So it's either going to be h or k. And since it's negative, we're going to go with h. The third one is a quadratic, but it's a quadratic that has a vertical reflection. So that's either A or I. Okay, so it's a vertical reflection, but we went to the right 3 and we go up 2. So this function matches I. Okay, this fourth one is the cube root function. So it's either going to be D, well, it's only going to be D because that's the only one we have. But note that D here also reflected vertically, which is what we see, and it goes right 1, down 1, which I also agree, because you could tell that like where the origin would be kind of down here a little bit, showing that right and down reflection. All right, this next one is the absolute value function, so it's going to be a V. So we're either looking at E or B, and it needs to go to the left and up, so we're going to go with E. The next one is the square root function, but it has a vertical reflection, so it's going to go underneath, so it's going to look like F or J. All right, so the differences between those two is that this one we're looking at goes to the left and only to the left 6, so it's F, but then if you look at the next function, we're going to go left and down 1, so this one is J. So we can cross those both off. The next function, x plus 1, is the line that goes through, or has a vertical shift up, and our last line left is k. This next function is a quadratic that goes to the right 4 and down 3, so that's going to be L. Then we have the absolute value that goes to the right 2 and down 5, so that's going to be B. And then a square root function that goes to the left 3 and down 1, which is C. And then yes, this is A, but we notice that there's a vertical reflection. It went to the left 3 and up 5. Okay, so now this function, the parent function, is going to be the square root of x. So you can say the square root function, or sometimes I even say a radical function. And this has two transformations. We're going to go to the left 2, because remember with x we're opposite, and we're going to go down 1. So knowing we go through the origin, I'm going to go left 2 and down 1, so now that point is down here. Also knowing we go through 1, 1, I'm going to start at 1, 1, and then I'm going to go left 2 and down 1. So to find some other points, you can plug them in for x and solve and get y. So if I plug in 2 for x, that's 2 plus 2, which is 4. The square root of 4 is 2. Minus 1 is 1. So we have the point 2, 1. So there's my square root function. So not only can you move the key points like 0, 0 and 1, 1, but you can also plug in any x value and get out a y value. So this domain is from -2 to infinity, and this range is from -1 to infinity, and we include -2 and -1 because we have a point there. Okay, so this function, the parent function, is just x because this is a line. This is a linear function. So we have a vertical reflection on the outside. That's what that negative does. We go left 3 and down 2. So I'm going to take the origin and I'm going to go. Okay, so the first thing I'm going to do is do any reflection, and then I'm going to go left 3 and down 2. So that's this point right here. The next point of the line would go through 1, 1, 2, 2, 3, 3. So if I vertically reflect those, then I would bring this point down here, and then I'm going to go left 3, 1, 2, 3, down 2. The second point up here would be down here, vertically reflected, and then I'm going to go left 3, 1, 2, 3, down 2. And this last one would vertically reflect all the way down here. And I could keep this pattern going, but I think I have plenty of points to draw my line. And then we all know the domain and range of a line is negative infinity to infinity. Okay, so now we have the square root function again, or this time I'm going to write radical, however you want to say it. This transformation is left 1, down 2. So I'm going to take the origin, I'm going to go left 1 and down 2. And I'm going to take 1, 1, and I'm going to do the same thing. I'm going to go left 1, down 2. Now I can find some other points if I'd like, but right here I can make my graph. My domain is going to be negative 1 to infinity, and then my range is negative 2 to infinity. Okay, graph D is an absolute value function. And the transformation on this is a vertical reflection, because we have that negative on the outside. We're going to go left 3 and down 2. Okay, so the origin is 0, 0, but then when we vertically reflect that, that doesn't change it because it's at 0. And then we're going to go left 3, down 2. So the next 2 points we're at the origin and then we're here according to the parent function. So if I vertically reflect this point, it's going to go down here, and then I'm going to move it left 3, 1, 2, 3, down 2, and it's going to be right here. This point over here, if I were vertically reflect it, it's going to go down to 1, negative 1, and then I'm going to go left 3, down 2, and I'm right here. And I have my points to make my absolute value graph. Okay, so for this next one, now whenever we have a number in front of x right here, we have to make sure we factor that out, because we can only have 1 next to x. And when we do that, when you take 2 out of 2, you get 1, but then when you take 2 out of 1, you get 1/2. So remember, before we name any shift, we have to make sure that there's a 1 right here in front of x. So the parent function is a quadratic. Okay, so a couple of different transformations are happening. We have a vertical reflection. We're going to go left 1/2, and then we're going to go down 3. Okay, so I'm at 0, 0. Oh, and I missed one. That 2 in front is actually a horizontal compression. Okay, so for the origin, we're going to start at 0, 0. Vertically reflect it, it's not going to go anywhere. Horizontally compressing it, it's still not going to go anywhere. So make sure you do any compresses, stretches, or reflections first. So we're going to still stay at 0, 0, and then we're going to go left 1/2 and down 3. Okay, so usually the parent function of a quadratic has these 3 points, right? And we just connect the dots like this. So let's take one at a time. Let's do, okay, so we have a vertical reflection. Well, let's do the compression first. So it's going to compress by 1/2. So we're going to multiply. So we have this point 1, 1, and we're going to multiply this x value, since it's a horizontal compression, by 1/2. So now I have a point at 1/2. I'm going to need to change the colors. 1/2, comma 1. Now I'm going to vertically reflect it, which comes down here. And then I go left 1 to right here. And then I go, no, left 1/2. Left 1/2 puts you on the y-axis. Okay, I'm actually going to start this problem over simply because I realize that your papers look a little differently than mine. So I'm going to draw on those points. I believe you have parentheses right there. So that means we're going to go left 1, down 3, and that is all that changes. Okay, so sorry about that. Again, so now we're going to go left 1, down 3. So here's my point. Okay, so once again, these 3 points on the quadratic, we have 1, 1. Now, it does horizontally compress by 1/2, so we weren't wrong in that regard. So now it's going to horizontally compress by 1/2, comma 1, vertically reflect down here, but then we're going to go left a full point over here. Sorry about that. And then we're going to go down 3. 1, 2, 3. So now we're right here. Okay, I'm going to switch colors again just so we can kind of keep this somewhat organized. So this point over here, negative 1, 1. Multiply the x value by 1/2, so you have negative 1/2, comma 1. So it's going to shift right here on the inside. It's going to vertically reflect down here, and then we're going to go left 1, down 3. So all you need to remember is that we have, whenever you have a reflection and a compression at the same time, in addition to left and right, do those first and then move left and right. My domain is all real numbers and my range is negative infinity all the way up to negative 3. And then I realized on that last one I didn't finish the domain and range. So your domain is all real numbers. And then my range is negative infinity up to negative 2. Okay, last graph right here. The parent function is the cubic function. We have a lot going on with this one as well. We have a vertical reflection. We have a vertical compression. We're going to go left 2, and we're going to go down 1. Okay, so the origin does not vertically reflect or compress, so then we're just going to go left 2 and down 1. Okay, so the points that we had were here, here, and here for a cubic function. So first thing I'm going to do is this one right here. So this is negative 1, 1. A vertical compression by 1/3 means now we have negative 1, 1/3 because we're vertically compressing it. So negative 1, 1/3 is about right here. And then you vertically reflect it. So it's going to go back up, and then we're going to go left 2, down 1, right here. And then over here we have 1, 1, but now it's going to become 1 comma 1/3, which is right here. Then you're going to vertically reflect it, and you're going to go left 2, and then down 1. So you're about right here. So it does take some time and some thought when you reflect and move around these functions. The domain and range of all cubic functions we know is all real numbers. Okay, so these next ones are a little bit different. We're going to start with 5a. So the first thing to identify is the parent function, and this is a quadratic, or the squaring function, however you want to say it. All right, so what happened? Well, the vertex is now at 2, 0. It's supposed to be at 0, 0 for the parent function. So that means we have a vertical reflection, and we must have gone to the right 2 as well for it to be at the point 2, 0. And to double check to make sure we didn't have any like stretches or compressions, the point that would have been at 1, 1 for it to be vertically reflected, and then right 2 would put you right there, which we have a point there. So we're good to go. That point right there confirms that we don't have any stretches or compressions. So with that being said, then we can now write the equation. Y equals negative x minus 2, because we went to the right, squared. Okay, so these next two are a little bit more challenging. So the parent function is going to be the square root function. Okay, what we do know, since this endpoint is usually at the origin, we clearly went to the left 3. And now the next point should be, if it was supposed to be at 1, 1, if we went left 3, it's supposed to be right here, but it's not. So how did it, and compared to this x right there in purple, it stretched vertically. You can kind of see that. So we need to write an equation and kind of solve a little bit to figure out how much did it stretch by. So what you're going to do is, you know that we have the function y equals, we're just going to say s for stretch, okay? And then we know that it went to the left 3, so that's x plus 3. So this is going to be our function, but now we need to solve for x and figure out, okay, well, what is that vertical stretch? And that's the only thing that's left, so that's all that we need. Now, we are going to borrow this point right here for the x value 6 and the y value 4.5 and solve for x. So that's going to look like this. We're going to have 4.5 equals s square root of 6 plus 3. Well, 6 plus 3 is 9. The square root of that is 3, so we have 3s. And then we're going to divide both sides by 3. And this gives us an s value of 1.5. That's acceptable, or you could say 3/2, up to you. So that means our equation is y equal 3/2 square root of x plus 3. And there you have it. There's your equation. Okay, so this last one. All right, so we have the absolute value as our parent function. Now we need to figure out the transformations. Well, the absolute value is supposed to go through the origin, so we clearly went left 4. But what else did we do? Because the next point is supposed to go through, if it was at 1, 1 and we went over left 4, 1, 2, 3. It's supposed to be right there, but it's not. It is off. So once again, it actually, since the line is underneath where it should be, that is a vertical compression. Okay, so let's figure it out. We know that we have y equals a vertical compression here. We can even use C if you want for compression. And then the absolute value of x plus 4, because we went left. And then that's it. So we're going to borrow this point 1, 4. So we have 4 equals C, absolute value of x plus 4, not x, 1 plus 4. And we get 5, the absolute value of 5 is 5. So we have 4 equals 5c. Divide both sides by 5. So c equals 4/5. And this is a number less than 1 and greater than 0, so that's definitely what we needed. So we have y equals 4/5, x plus 4 for our equation.